Hi everyone, I'm teacher Felicia from Overmark. For the free revision lesson today, I will be doing for Sec 3 IP Physics, and the topics that I'll be doing today would be physical quantities and kinematics. Okay, so let me just give you a little bit of a brief introduction first before we start with the lesson proper. So for all students, please scan the QR code that is on the top left of the screen so that you can download the lesson material for today. Okay, so a little bit introduction about myself. So I'm Miss and I specialize teaching IP sciences. So I teach from Sec 1 to Sec 4. I teach Sec 1 and Sec 2 science, and for Sec 3 and 4, I teach chemistry and physics. And for me, previously, before I joined Overmark, I was actually teaching at the Learning Lab for 7 years. And before the Learning Lab, I was teaching at the other tuition center called Wasteland. And during this period of time, I also did a lot of like relief teaching at the various MOE schools. Yeah, so this is so far my track records as I mainly specialize in teaching IP science. So my students are mostly majority, they are from NYGH and RGS. Yeah, but I do have students from other IP schools also like SIDA, St. Nicholas, Cat High. Yeah. So just a little bit more about myself. So personally, I really love traveling. So here are some of my travel photos. Yeah, so during my most recent travel in Switzerland, I actually like tried for my first time like paragliding. Yeah, so this is me doing paragliding. Yeah, and that I also like love Korean shows. Yeah, I like watch K-drama. I like to watch like Korean variety shows too. Yeah, so I actually tried to find like the filming locations of where the filming sites are at, yeah, at Switzerland. So this is actually, I don't know whether do y'all watch the drama series Crash Landing on You? Yeah, so that's where it is being filmed. Yeah, and while I'm traveling, I also want to like I will also think of teaching. Yeah, because teaching is really my passion. Yeah, so while I was like at super high altitude, as you can see over here, then I realized that oh, the sandwich that I brought up to such high altitude, it actually is like very swollen in the packaging. Yeah, so let me just show it to you. Yeah, so could you see that the packaging swelled? Because normally for the bread wrapper, it's not so like full, right? Yeah, so what's going on over here is because of the difference in the altitude, which results in the difference in the pressure. Yeah, so the pressure on the inside of the bread, it is very high, much higher pressure than the outside because at higher altitude is where the pressure is very low because there's very little air above us. Yeah, so when the outside pressure is very low, but the inside pressure is super high, the particle is like trying to like push outwards. That's why you can see the packaging is like swollen. Yeah, so that's me. Yeah. Not forgetting about my teaching job when I'm even overseas. Yep. Then I also love board games. Yeah. So some of the board games I actually played with my students during lesson time too. Yeah. So this is like one of the game that I played with my students, which is called Wet Heads, where like usually I'll get them to like study some important concepts, and then if they never study, then as a punishment they need to pull out one stick. Yeah. So if one of the stick so out of all 8 sticks, only one will read water. So it's kind of like your own luck. Like if you never study, this is your punishment. But if you're lucky enough, you might be able to dodge the punishment. Yeah, so only those who didn't study then need to put a stick and might get punished. Yep, so that's the wet haze. Yeah, then these are card games, which is called the ion card game, where it's to form chemical formula. Yeah, so these are some of the games that I play with my students. But of course, there's more too. These are just a few examples to name. Yep. So besides about myself, let me introduce to you about Overmark so that you can know more of Overmark in case you never heard of. So for us at Overmark, we actually teach secondary Sec 1 to Sec 4 as well as IP, which is like Sec 1 all the way to JC 2 as well as JC A level tuition. So right now for Overmark, we are located at these 7 locations. Yep, so we have 7 branches across Singapore, and so far there are about more than 5,000 students that's under our care. And you can also find us easily on these social media channels. So if you haven't followed us, I recommend you to follow the Overmarks social media channels because that's where you can actually get updates on like free like freebies. Like for example, like today is this free WA1 revision lesson. Yeah, it's also shown on the social media. Yeah, so then next time in future, if we were to distribute like free materials, free revision worksheet and notes, and then if you follow us, then you will be able to know how to receive it. Yeah. So far, this Overmarks track record, 70% of Overmark students actually achieve A1 and A2 in O levels and A levels. Yep. And for all overmarked tutors, we are all at least university graduates. Yeah. So a lot of us also have like very strong teaching background. Yeah. So there are a lot of teachers who are previously from MOE schools, and like myself, yeah, I'm from like Learning Lab. Yeah. So there are also other ex-Learning Lab tutors in Overmark too. Yep. And for Overmark, we mainly focus on trying to create like more engaging and vibrant learning environment. So as our students, if you are our student, then yeah, you will get the best learning resources. So you will get to receive like curated notes. So even for topics that you haven't joined tuition yet. So maybe if you are like a Sec 3 student now, you only join like maybe in February, but no worries, you won't miss out on the January notes because we do give out the whole range of curated notes. Even as a Sec 4 student, if you were to only join Overmark at Sec 4, you will still be able to receive from Sec 1, Sec 3, the first Sec 3 topics till the last Sec 4 topics curated notes. Yeah, and we will also prepare you for WAs, prepare you for exams. And when nearing practical period, we actually have hands-on practical lesson. As you can see, that our students are like doing the titration experiment here. Yep, and we also have like a lot of summary cheat sheets, as well as if you have anything unsure, you can also like consult the teachers. And actually, not only consultations, our teachers are very reachable. You can even text us, then we will also like reply to your enquiries for our regular students. Yeah. So for the lesson material for today, if you have not downloaded, can you quickly scan this QR code? Yep, then I'll begin with the lesson now. Okay, so yep, let's begin with the lesson. So this is the lesson material for today. So for today, we would be doing on physical quantities, units and measurements, as well as kinematics. Okay, so let's start off with physical quantities first. Just to let you know that for this topic one, this is actually our regular lesson notes. So you can actually see for yourself, like if you were to like join us at Overmark, this is the quality of the notes that you will be receiving. Okay, so the first part here is just a checklist. So if you are going to have WA soon, you can check through the checklist to make sure, do you remember and know everything? So if you understand everything, then yeah, you are ready for exam. But if not, then yeah, make sure that you cover all the learning outcome here so that at least you won't miss out anything that is important and might be tested. For the lesson today, as it is only 1.5 hours and I need to finish up 2 topics, which is very short a time, so I won't be doing all these. I will only be doing from A to E. So for F and G, because don't have time, so I will be skipping for today. So F and G actually will be covered again more in detail in the topic of dynamics. Okay, so for the first part over here on uh, base quantities. So need to know that total, there are only these 7 base quantities. So if you were to see anything else that is not within the list of these 7, then they are not base quantities. But take note that sometimes they can name it a little bit different. Like for example, if it is length, you can also write it as length become distance. It can also be called height, but it still refers to the base quantity, which is like how long things are. So can you follow and note it down? Yep. So just to let you know that for my lesson style is whatever that I write on the screen, you follow and write it down too on your copy. Okay. Okay, then next thing to take note is that for the units, it would be that for length, the unit is in meter. But then if it is for the quantity, M, it can also represent mass. That means in other words, M depends on is it quantity or unit. If it's a quantity, it is mass. But if it's a unit, it's meter. So just take note that M appears twice. And then for mass, the unit is kg, not grams. And for time versus temperature, take note, small t versus big T is totally different quantities. Yep. So make sure that you write with the correct caps or small letter. And for time, it is in seconds, not minutes, not hours. Temperature, not degrees Celsius, not Fahrenheit, but it's Kelvin instead. And good to know the conversion between degrees Celsius and Fahrenheit. So let's write it in. So the amount of Kelvin is actually the amount that you see in degrees Celsius plus 273. That means, in other words, if you were to have 0 degrees Celsius, we would say that this is equivalent to 273 kelvins. Because if it's 0 degrees Celsius, you put 0 on the right side. 0 plus 273, you will get 273 Kelvin. Okay, then next would be electric current, which is in ampere, I think no problem. And then amount of substance, letter N, it has a unit of mole. You will learn the last one over here on mole in second half of Sec 3 chemistry. Yeah, so you'll be learning this soon. Okay, I take it that you all should be done copying by now since not much to highlight and write it. I shall move on to the next part. Okay, so for the next part over here on prefixes, need to know all the base quantity as well as its letter to represent it and how big and how small it is, and must have some general sensing of how big and small these quantities are. So over here, they are showing you in terms of meters, like terameters, it will be like Earth's orbit diameter. Then if it's like decimeter, it's like the length of an A4 paper. So need to roughly know because sometimes they might ask you some of this kind of like the common sense type of question. Yeah, so need to roughly know how big or how small it is. Yep, so let me now show you this website where they would tell you how big or small these prefixes are. So let me show you this. Let me hold on, sorry. Um, wait, it's a bit distorted. Just try to refresh it. Ah, yes, okay, it's better now. Okay, so for this website over here, they will be showing you how big or small all the prefixes are. So we start off with no prefix first. So without any prefix, it would be like in meters. So this would be like us human, because like maybe my height it is 1.6 meters, and then it is just meters without any prefix. And dodo bird is also like one of the very big size bird, is 1 meter tall, and it went extinct is because it's too big. It couldn't hide from its predators. Okay, then if you were to look at things that is like smaller than that, so if it's smaller, that means we are going into the smaller prefixes such as here, deci and centimeter range. So what are the object that is in deci and centimeter range? It will be things like birds, mouse, chicken egg, marbles, yeah, ants, yeah, all these are really small, like sunflower seed, duck wheat. Yeah, so these are all in the centi and decimeter range. So next, it would be the millimeter range. So millimeter, it would be 10 to the power of -3 as seen from the notes over here. Can you see? Milli. So now let's take a look at what are the things that is in millimeter range. It will be things that you can still see. That's why you can still see like paper, right? You can still see the thickness of the paper. Yep, so as shown over here, the thickness of the paper, it would be like in a width that you can still see, like the width of one strand of hair. So if you were to look at one strand of hair, you can still see the hair. That means it's still in millimeter range. And then even for the human egg, how big is it? Like for me, female, I produce a ovum. You just take your pen to do a quick full stop, then you will be able to see the full stop, right? So if you can see, means it's in the millimeter range. Yep, so actually female egg is the largest cell in the human body. That's why it can still be seen. So anything that is smaller than this size, which is things that is smaller than the ovum, we will not be able to see. Then you need to use the microscope, light microscope to see, such as like skin cells, like all the different kind of cells like red blood cell, white blood cell, cell nucleus, chromosomes. Yeah, all these you need to use light microscope to see because they are too small in terms of millimeter. So next, after millimeters, it would be micrometer. As you can see over here, that milli, you become micro. So for the micrometer, it would be like viruses. Yeah, but micrometer generally not quite visible by light microscope anymore. So things that is in the micrometer range, you can't use light microscope. Then we will have to use the more specific, more precise microscope, which is the electron microscope. So things that can be viewed by the electron microscope will be like these things, like the different viruses, DNA. This is actually the cell membrane. So actually, when you draw a cell, right, the cell membrane, one layer actually is split into double layer. So these two layers is the cell membrane. Yep. So all these are all in the millimeter range. So sorry, the micrometer range. Then after micrometer, so done with micro, which is 10 to the power of -6. Next would be nanometers, which is 10 to the power of -9. So nano, it would be like really, really small. That's why you know, like they say what nanotechnology. Yep. So nanotechnology would be things that is like atom size. So you see like carbon atom, water molecules. So this would be all that the electron microscope can see. So if you were to look at things smaller than electron microscope, then you will have to use like technology to do an estimation lah. Yeah, so what are things that is even smaller? So it will be like what's inside the atom? It will be like your nucleus and your subatomic particles. So you start to see like nucleus appearing. Yeah. Then you see proton, neutrons. Yeah, lor. Okay, then yeah, so now I shall shortcut and zoom all the way in. Okay, so maybe I just zoom all the way in to see what's the oh, by the way, in case you're wondering what's all these quark, many different quarks form your proton, neutron, electrons. Yeah, they form your subatomic particles. So what's the universe smallest object? Yeah, it would be this. Yeah, so quantum foam is actually some space-time theory and all linked to quantum mechanics. Yeah, so it's like really, really small. Then for the string here, it's not the string to sew our clothes, but this string here is more of the string that is like a string theory, where object that is like one dimensional kind, yeah, they fall under this string theory. Yeah, so they are not really like a two dimension because all object usually is like 2D, but this is like one dimensional. Yep. So now let's zoom back to where we started off from, which is human. Ooh, okay, over here. Yep. So this is where we started from. So now let's take a look at things that is bigger than us. So it will be like the larger size animals like giraffe, elephant, airplanes, trees, Eiffel Tower. So all these you will start to use the bigger prefix of kilo. So it will be things that is in the positive magnitude. So you see earlier on, the ones that we have been looking are all the ones that is negative. Now let's take a look at the positive ones. So like kilo. So for kilo, it would be things such as like those man-made structure. Yep, as you can see, yeah, Mount Everest and all. So all these are in the kilometer range. So things that is bigger, it will be the megameter range. So megameter, it will include like the bigger countries. Yep, and things beyond the megameter, like you see over here, there are the planets. This would be beyond mega. After mega, it would be giga. So giga, it would be 10 to a power of 9. Yep. So things that is in the megameter range, it would be like this kind of planets. And as you can see, Pluto, do you still remember that Pluto is actually a dwarf planet, not an exact planet? The reason is because, as you can see, the size of Italy, if you were to combine two Italy, right, it would actually be about Pluto. Come, let me show it to you. So if I were to shift the length that I'm measuring, could you see that kind of two Italy forms a Pluto? Yeah, so this shows that Pluto is really, really tiny. Yeah, so that's why Pluto cannot be considered as an actual planet. That's why it's a dwarf planet. So things bigger than dwarf planet, it will be the actual planet. Or maybe if you play game a Minecraft world, yeah, Saturn and all. Yep, so these are in the gigameter range. So things beyond the gigameter range would be the terameter. So terameter would be bigger than the planet. That would be the various stars. So the stars for us, it would be the sun. Yeah, so there are many different stars for the different systems. So what is bigger than the stars? So bigger than the stars, it would be the nebula. So the nebula, very cute one. The name, they just follow the shape. So you see, it looks like stingray, then it calls stingray nebula. Then next one, it looks like ant, then it's called the ant nebula. Yep, so there are many different nebula. Then what's bigger than nebula? It would be galaxy, as you can see over here. And what's bigger than galaxy? By the way, galaxy already reached zeta meter. Yep, so this is the one that we are in, that Earth is in. So Earth is in Milky Way galaxy. So things that is bigger than galaxy, it will be called the clusters, as you can see over here. So for our technology, there is a limit to how far at the outer space we can actually explore. So this is the observable universe. Things beyond that, there are things present beyond that, but we are unable to observe. Yeah, so this is actually how small we are. Yeah, because there are so many things that is bigger than us. Oops, overshot. So yeah, we started off from here. Yeah, like that. So hope you can now have a better understanding of how big and small these quantities are. Yep, so hopefully better able to visualize all these object sizes here. Okay, so next part, moving on to the next page, it would be on the derived quantities. So for derived quantities, it would be those that is not from the seven on the previous page. So if it's the seven here, is called the base quantity. Let's highlight clearly also. Yep, so over here, this is the base quantities. So need to know that in physics, for physical quantities, let me scroll up a little bit. So for physical quantities, you can subdivide them into two categories. It can be called base quantity or physical quantity. Can you follow and copy it down on the first page too? For base quantity, it's only these seven. But physical quantities, it will be everything else except these seven. Done right? Okay, then we move on. Okay, so moving on to the next page. So for derived quantities, if the question wants you to express it in terms of the base unit means the base quantities unit. Yeah, so if they want you to express only in these seven units, so what you need to do is you just need to keep converting them into the base quantities. So like for example, if they ask you for power, you have learned before, right, that even in lower sec, PET formula, the pet animal formula, PET, pet. Yep. So now you just check is energy and time base quantities. So you check here. Energy is not in here. But time, yes. So that means time, you don't need convert anymore. Just convert energy will do. That's why you convert the energy. And energy is similar to work done, which you learned before in Sec 2, right? Last year. Yep. And work done, you have learned that it is force times distance. So that's why they change it to force times distance. Then now, same thing, you check back the list of seven base quantities. Is force and distance base quantities? So force is not in here, but distance, yes, right? Because just now we annotated that length is can be called as distance. Yeah, so distance is a base quantity. So now we just need to convert the force away because force is a derived quantity. So what is force? So soon you will be learning that force in the next chapter, third chapter called dynamics. Force is actually mass times acceleration, MA. And then same thing again, just check M and A, mass and acceleration in the list. So by looking at this list, mass, yes, but acceleration is not in this list. So that's why for acceleration, you have to continue to convert. That's why until when you get them to be the base quantities, then yep, done. So in this case, yeah, so it's just keep simplifying. Yeah. Actually over here the acceleration, in case you don't understand how come you can get this, you can just convert to the one that you learn in kinematics, which is A equals V minus U over T. That means you can express A as speed over time. Yeah, that is why suddenly there is like the time square appearing, yeah, because there is speed. Yeah, so you just slowly convert and convert lah. Yeah, then you can eventually get this also. Okay, so then so eventually the answer should be in all the base units as you can see from the previous page over here. Okay, then I shall move on to the next part here on conversion of units. This is very commonly tested because need to know how to convert when they give you like with certain prefix that is shown in the previous page over here. So if they were to add in any of this alphabet before your unit, they need to know what it means. So by the way, one of the way to easily remember for mega is you can go with M for mega, M for million. That's why you see it is 6 zeros. Then usually the bigger prefixes, it will be bigger letters. So can you see? These are bigger. That's why this would be bigger letters, also called capital letters. Then those that is smaller, like those that are negative, the smaller prefixes, they tend to be in small letters. Yeah, so this is one way to remember. Yeah, you can write this down too. Okay, so over here, how do you convert the units? So the ones that is in here, I think I shall not go through. You can slowly read it on your own. Sorry, I need to like move on a little bit faster because I would prefer to set aside more time for kinematics, which is more difficult. So since all this here I explained very detailed that they really write out step by step, you can just go and read through it at your own time. I shall maybe use more other examples to explain to you. So generally, the rule is that whenever you want to like remove or add a prefix, what do you do? So the rule is if you want to remove prefix, you should always multiply with the magnitude. Can you follow and copy it down? After you are done copying, I then explain to you what it means. Okay, so for example, like over here, this is given to you in kilometers, right? So if they give you in kilometers, how do you remove the prefix? So it's like how many meters this is. Okay, I think you can visualize easily kilometer to meter. But maybe if I were to give you a little bit more complex, so maybe if I say that, oh, I want you to convert maybe I put an example here, 1.53 1.54 kg, I want you to convert to milligram. Then how do you do the conversion? So the rule over here is you can give it a try to see whether this method suits you. If not, you can still stick to what your school teacher teach you. So how I will usually go about doing it is first, I convert it to without prefix first. That means I just change to gram first. So since I'm removing prefix, remove means that I should times the magnitude. So I will check for kilo is times what is the magnitude. So by looking at the previous page, kilo, the magnitude is here, 10 to the power of 3. That's why I will just follow the instruction and put in 10 to the power of 3. So this would be 1540 grams. Then next, from gram, I now need to add in prefix. So when you add in prefix, it would be divide the magnitude. Then now I will check milli. What's the magnitude stated in the notes? Milli is over here. Milli is 10 to the power of negative 3. That's why now I'll write it as 10 to the power of negative 3. And you can give it a try to press the calculator to see 1540 divided by 10 to the power of negative 3 is how much. And you will realize that, oh, the answer, it would be 1540000. So this would be the answer. So this is like method number 1. Method number 2, it would be that you can compare and make sure that the equation must be equal. That means I look at my unit. My unit from kilo become milli. Kilo is very big, right? Milli is very tiny. So if my unit becomes smaller, and since the equation must be equal to each other, that means my number should become bigger. So that number become bigger, prefix become smaller, they will still be equal to each other. Then now I will check from kilo to milli, what is the difference in the number of zeros? So by looking over here, kilo is 10 to the power of positive 3. Milli is 10 to the power of negative 3. So total, it would be a difference of 6. That's why I now know that I need to shift by 6 0. And the 6 0, is it shift it bigger or smaller? So as shown over here, the number should shift 6 zeros bigger. So that's why I shift by 6 zeros bigger, then you will get this answer. Yeah, so this is how you use this method. Yep, so there's 2 methods. Method 1 is you just follow the rule above. Method number 2, it would be you just compare and make sure that it must be equal. So if unit become bigger, then number should become smaller. Yeah. So yeah, so this is a conversion. Then sometimes they won't be so nice. They may not only give you like just kg and mg. They might give you like maybe in terms of let me put another example here. Maybe the unit has 2 quantities, like maybe this kilometer per hour, then they want you to convert to meter per second. And then in this case, how do you convert? So what you do is you always write it as a fraction. So it's 108 km slash means divide by 1 hour. And since the question needs it to be in meter per second, right? Then you just convert lor. 108 km is how many meters? And this one, I think you can mental sum and know it very clearly, right? That it is 108,000 meter. Then 1 hour has how many seconds? 1 hour has 3600 seconds. So after you press the calculator, by right, this should give you 30. Then this would be the answer. So when there is a slash, you just put it as a fraction. Another type of question, let me just squeeze it in over here. It would be involving squares and cubes. So for example, like if they were to give you like such numbers, then they ask you convert it to dm cube. So how would you convert? So whenever there is cube, you start off with number 1 first. That means you start off with 1 cm is how many dm first. Start with 1. Don't start with the 47 point something. So you just refer back to the previous page. Centimeter is over here. Decimeter is over here. So for centi is actually smaller. Deci is bigger. So that means in other words, 1 centimeter would be 0.1 dm cube. 0.1 decimeter, right? Because centi is 0.001, but deci is 0.1. Yeah, deci is bigger. Okay, then now you go and cube it. So if you cube it, you cube the number, you cube the unit. Yeah, so just cube everything. So in this case, if I cube it, then it will become 0.001 dm cube. Okay, wait, let me just write the proper working first. Yeah, so I cube everything. So after you cube everything, then now you just press the calculator to see what's the answer. So you will get 1 is just 1 itself. 0.1 you cube it, you get 0.001 dm cube. Yep, so that's why in this case, if they ask you for 47.57 cm cube, that means you just multiply 47.57 on both sides. Yep, so after you multiply 47.57 on both sides, you should get 0.04757 dm cube. Yeah, then this would be your answer. So whenever you have any squares or cube, you start off with 1 first. After you start with 1 already, then later you then sub in your value. So that's why the answer here would be 0.04757. Yeah, like that. Yeah, so need to know how to do all these conversions. You can continue to practice the conversions using the examples given in the notes. Okay, then I shall move on. So just to check, are all of you done with all the annotations? If done, can you click the Zoom reaction button? There's a reaction button which is a thumbs up sign. Yeah, so can you click that? Then I'll then move on after you are done copying. So Judy, when done copying, let me know. Is Judy around? No response? Okay, then I think I shall move on. Okay, so moving on to the next page over here. So they are just telling you that for each of the instrument, how small you can measure until. So all these I'll leave it to you to study on your own because it's just facts, nothing much to understand. Okay, then next part would be measurement of time. So need to know how to calculate when they ask you for time. So take note that in this section over here, there are 2 main keywords. Number 1, oscillation. What does oscillation means? Oscillation means swing. That means 1 oscillation means 1 complete swing. So 1 complete swing would be from A, you go to B, B back to A. Because if you swing to the right, you also need to swing to the left, need to balance up. Then another word need to know, it would be period. Period would be the time taken for 1 swing. So that means oscillation is the motion itself, but period is the time of the oscillation. And take note that even though question is only asking for period, which is for 1 swing, but whenever we conduct the experiment, we always conduct for 20 swings. The reason is because of the human reaction time. Yeah, because for human reaction time, it's about 0.4 seconds. So if you were to do only for 1 reading, the significance of the human reaction time is huge, as shown over here. Why do we need to have to take 20 oscillation and then repeat the experiment? Is because for human reaction time, let's say if my human reaction time is 0.4 seconds, and if 1 oscillation takes 1 second, if you look at the percentage of this human reaction time error versus if I were to do for 20 swing. If 1 swing is 1 second, 20 swing would be 20 seconds, right? So do you realize that once I do it for 20 seconds, the amount of human reaction time, its percentage error is so much smaller. So this would then reduce the random error such that we will be able to obtain a more accurate result. Yeah, so that is why even though question asks you for only period, which is the time for one swing, but we will still do for 20 swings. Okay, then next would be need to know what are the factors that would affect the time taken for the swing. So take note that only length will affect. No matter what you change, like you change the mass, you change the angle, you change the shape, the time taken will still be the same lah. Yeah. So only length is the only factor that would affect the oscillation. The rest, I will leave it to you to read on your own because these are just like trying to predict all the possible type of question, and these are the model answers. So if they were to ask you such question, you just write in the model answer. So the rest are quite easy to understand, so I'll leave it to you to read on your own. Then next would be besides sentence writing type of question, they will also ask you calculation. Yeah, so for example, like if they were to say that if I were to say that my experiment, right, I start off from the center. And then when I start from the center, once I so that means I let it swing, swing, swing for a few times. Then once it passes through the center, I start the stopwatch. So once I start the stopwatch from here, I count as, okay, it passes through the center one time. So if, for example, if I said that the pendulum bob passes the midpoint over here 9 times, including the first time when I start the stopwatch, then I say that, oh, by the time it reached 9 times the center, so that means like once I reach the center, I start. So it's counted as 1, then 2, 3, 4, 5, all the way until it reached 9. Then I would say that, okay, I press the stopwatch to stop. And I realized that, oh, it actually takes 10 seconds. And now my question is, do you know how long is one period? So period is capital letter T. So how long is one period? So you need to know that for the first swing, because you started counting from here, okay, let me draw it out. So if you start from the middle, then you have to swing to the right, swing to the left. This is passing through the midpoint second time, right? Then if you swing to the left and you come back, this is the third time. So do you realize that for your first oscillation, isn't this one oscillation because you have to swing to the right and swing to the left to complete as one oscillation? So the first oscillation, you realize that you will pass through the midpoint 3 times. If you continue on for the second oscillation, every oscillation you need to swing to the right side. You also need to swing to the left side. So do you realize that for my second oscillation, it is actually passing through the center 2 times? Then if I continue on, so if I go to the right, pass through the center, go to the left, pass through the center. So this would be my third oscillation. Yeah, so overall, you realize that second oscillation onwards, you will only pass through the midpoint 2 times. The only exception is the first oscillation, where you actually pass through the midpoint 3 times, because the first time when you start the stopwatch, you count it. Yeah, so that's why what usually we will do is to find the period, what we will do is we will exclude the first oscillation first, because this is like exception. So if I were to say that pass through 9 times, I would remove the first time, which is 3 oscillation. That means now I know, okay, I'm left with 6 time passing through the midpoint. And since we know that each oscillation pass through the center 2 times, so let me write it down over here. One oscillation will pass through the midpoint 2 times. Now that I remove for my first oscillation, the swinging through the midpoint 3 times, that means now I know that I will continue to swing through the midpoint another 6 more times. So that's why, based on what we see over here, if 2 times means one complete oscillation, 6 times means it would be 3 complete oscillation. Yeah, so because you times 3 ma. Yeah, so that means now I know that, okay, so once I exclude the first time, because this is what I was trying to do, I wanted to exclude the first oscillation, which has different number of time that it swing through the midpoint. Once I exclude the first time, I know that, okay, I will be left with 3 oscillation. And if I continue to label it, you realize that it will be true. Because here you see, if I continue, 7, go there and come back. Number 8, go there and come back. So you see, isn't this the fourth oscillation? Yep, so this concludes that besides the first time, I have 3 more other times, which is over here, which you can see is 3 more oscillation. That's why total it would be 3 oscillation plus the first oscillation. Total it would be 4 oscillation in total. And 4 oscillation is 10 seconds. So now I will do the math. Then 4 oscillation is 10 seconds. That's why to find out one period, which is one oscillation, it will be divided by 4. That means it would be 2.5 seconds. That's why the answer for one period is 2.5 seconds. So this is how you deduce. This is quite a common type of question. So if you still not quite sure on what I'm trying to say, you can read through the word example, which is on the next page. Next page. Yeah. So it's actually on page 7. There's a similar question. Okay, so just to check, are you all done noting down everything that is like written? So once you're done with all the annotations, can you click the thumbs up button to let me know? So done copying, right? I move on. If you're not done, you can maybe take a screenshot. Then later you can copy it down at your own time. Can, right? Okay. So I see that there's a new attendee. Yeah, I've just sent the lesson material into the Zoom link. You can go and download from there. Okay, so continue on to the next part. All this I went through just now, some of it. This one is just extra info. You want, you can read. If not, it's optional. It's just extra info. Yeah, so the question that I was trying to ask you just now is this kind. Yeah, so you can also go and read through it. There is also explanation over here. You can give it a try first to see whether can you get the answer of D. If you can get it, means you understood my explanation just now. But if not, you can just try to write out the working, just mimic the example just now, and then you can read through the way they explain to deduce how to get the answer. Okay, so next part over here, it would be on random error versus systematic error. This one, I think your school teacher should have mentioned to you already. So I think I don't want to go through in detail anymore. Random, as the name suggests, is just random, which you cannot eliminate. Yeah, you can only at max minimize. Yeah, so cannot eliminate. As compared to systematic error, can eliminate. Yep, so since you cannot eliminate, you can only minimize by repeating the experiment and find the average. Systematic error comes from the word system. That means it's like the system fault, the equipment fault. Yeah, so this kind, usually once you know your equipment is faulty, you can eliminate it by replacing the equipment, or maybe you just remove the zero error. Moving on, should be done highlighting the keywords, right? And writing the word like can eliminate or cannot eliminate, right? Okay, so next part, it would be precision versus accuracy. For the definition for precision, can you just double check your copy and make sure that it's the same as what's shown here? Because the previous copy, the definition for precision inaccurate. It should start from the reproducibility of repeated measurements. So you just make sure that your copy is the same as what's shown on the screen will do. So for precision, it would be, as you can see from the top here, is about how can you always keep making the result to be consistently the same. So this is considered high precision because the values are all very similar. And the left side over here also, this is high precision because you see the values are always the same. So precision is about whether can you keep producing consistent values or not. Are the values close to each other or not? Yeah, so it's about how close the values are. As compared to accuracy, accuracy is whether do you hit the correct answer as shown in the teacher's answer key. So it's about whether do you get the actual value or the true value. Yeah, so is it yeah, so is the value correct? Like does it hit the correct answer key? So for precision, it will be affected by random error, while accuracy is affected by systematic error. Because if you don't have random, because random can be like sometimes bigger, sometimes smaller, because it's random. That's why if you don't have the random error, your number will be close to each other. But systematic error is like, for example, if my weighing scale, I haven't stand on it, it already reads 5 kg. then isn't it mean that no matter how I conduct my experiment, it will forever be extra by 5 kg? It means I can never ever hit the correct value, correct mass. So that's why accuracy is affected by the systematic error. So how do we eliminate it? As mentioned, for random error, you can at most just repeat the experiment by taking multiple measurement and find the average. Then for the accuracy, which is affected by systematic error, as you can look at the table above, systematic error is system fault. Just replace with another okay apparatus, then by right you should be able to get the accurate values ready. Yep, so that's why the reason is as shown over here. Likewise, for the nerds, it's just extra info. You want, you can read through it. If you're not interested, you can skip it. Yep, so over here, these are the practice questions, which I won't be going through because I find that the questions here are still simpler because it's only the first chapter. So you shall give it a try at your own time at home. I will be providing the answer key to these questions at the end of the lesson. So just stay till the end. I will give you the answer key. Then after you are done, you can check through your answer to see if it's correct or not. Yeah, so I think manageable. So you will try it on your own. I move on to kinematics. Because kinematics is tougher. Okay, so for kinematics, likewise, I won't be able to go through so many learning outcome. So I will be only focusing on some parts. I will be focusing mainly on graph. That means like how you interpret the graph and how you do graph conversions. So calculation wise, that will be a little bit lesser. Sentence writing, I am going through. Yeah, so that means my priority would be graph. Then sentence writing, I won't be doing much on calculation because I think you can just practice it with like all the different practice paper. The conversion, I think that kind need like verbal explanation. So I think I would go through that more for today. For kinematics, this would be all the equations. So depending on your school, if your school, because I know that for the IP school syllabus, some IP schools they really like teach you the A level content. Yeah, so if you need to know the equations of motion, then you will need to know the last four formula. But for some IP schools, although you are in IP stream, but teachers still follow the MOE textbook. Then if you follow the pure physics MOE textbook, then you will only need to learn the first two formula. The last four don't need. So last four is depending on your school. So for each of the alphabet, by now you should know what each of them means. So I don't want to go through in detail anymore because you should at least know the foundation by today. Yep. Okay, so let's try out some questions to see whether you know how to apply these formula in. So let's take a look at question number 1 to see whether do you know how to solve questions related to average. By the way, before I move on to question 1, just wanted to emphasize that whenever they ask for average, take note, you must always find in terms of total. So it's total distance divided by total time. Or if the question were to give you in terms of average velocity, then you just do likewise. So once your speed become a vector quantity, it becomes velocity, then your distance should also become a vector quantity. So instead of total distance, the vector version of distance is displacement. But time don't have a vector version. So time, you just continue to write it as total time. Can? Okay, then now, can you give it a try to do the MCQ question number 1 that's related to this formula? Yep, so do now this question here. Once you are done, can you PM me your answer on Zoom chat? Then I can let you know whether is your answer correct or not. Yep, do now, do now. Yeah, do question number 1. This is on page 21. Winton, yes, your answer is correct. Good. Then, Winton, since you are done, you can give it a try to do question 6 if your school teach you on the equations of motion. Once you're done with question 1, you can move on to do question 6. If you all can't solve question number 1, you can type the word don't know also, okay? Then later I'll explain it to you. Yeah, so if you can solve, you tell me your answer. If can't solve, you type the word don't know. Then I'll go through later. Let you all try first. Monish, not correct. You give it a try with question number 6 first, meanwhile waiting. Ella, correct, very good. I see that there is like a new user who just came online. Do you have the lesson material? Do you need me to send you the link for the lesson material shown on the screen here? The class, they are trying out question number 1 on page 21 now. Risha, yes, correct, very good. Then move on to do question number 6. Are the rest of you all right? Okay, I think I shall go through now. KJ, no, not correct. I shall go through now but on how to solve. I believe most of you should be able to solve the, let me see the answer that you got. Okay, I think some of y'all, the average speed is incorrect. Okay, so remember just now I was saying that what's average speed? Average speed is always total distance divided by total time. Okay, so let me write in the working. So for those of you who got it wrong, please copy down the working so that next time you know how to solve it. By the way, just to let you know, later for the answer key that I will be sharing at the end of the lesson, the MCQ, I will only give you the ABCD answer. I won't be giving you the working. Yeah, so please copy down the working because it won't be provided later. Okay, so for the average speed, the total distance, as you can see, is here. And there is no need to change the unit because the unit for the answer is also in km. So that's why for this question here, what's the total distance? You just take 120 plus another distance of 60 divided by total time. Total means all the time must be included, including the taking break, because it's the total. Yep, so total will be 90 minutes, but check the units. This is in hours. So need to convert to hours. 90 minutes is 1.5 hours, right? So that's why I'll write down 1.5 hours plus 30 minutes. 30 minutes would be half an hour plus 50 minutes. So 50 is like 50 over 60 hours lah. Then if you go and press the calculator, this should be like 0.833333 like that. Yep, so I'm going to write down 0.833333. Then you press the calculator. This would give you the answer for the first column. Hello, Clover, who just logged in. Clover, do you have the lesson material? Do you need me to send it to you? Okay, so then you will get the answer of option A, correct? Okay, then this is in 2SF. Okay, then now moving on to average velocity. So average velocity, as mentioned, it would be total displacement divided by total time. So for displacement, take note that you need to take into account the direction. So that means the north, east, you must take into account. So let's draw it out first. If the person travel 120 kilometers north, which is like this, so 120 kilometer north, and travel 60 kilometer east. So what's the displacement? Remember, displacement is always from the start point to the end point. So you just connect from start to end. So once I connect from start to end, this would be the displacement. So you realize that this is actually a 90-degree right angle triangle. So how can you find the displacement? You have to use Pythagoras theorem. So this displacement over here, this value is the c square equals to a square plus b square. So I'm going to write out the working over here. To find displacement with c square, it will be equals to a square plus b square. So I'll take this plus this. Then now you go and solve out what is the displacement. So displacement, it would be the square root of the value there. Then once you solve out what's the value of the displacement, you sub it into this formula. And the denominator is still the same, right? Because it's still total time. Yep. So once you found the total displacement, you sub back the same value for total time. Then you give it a try to see in the end which answer did you get. Yep. So for Monish and KJ, you calculate out, then you let me know what's your new answer now. Hello to the new students who just joined in this session, Ashley and someone with the letter C. Would you need the lesson material that is shown on the screen over here? So KG, now your answer is yes, correct already. Yes, good. You can write in your correction. So so for Monish, what's your new answer now? Can solve? By the way, once you are done with question number 1, can you move on to do question number 6? Yep, so the task now is question number 1, the working is shown on the screen here. Then do question 6, the open-ended. So for those of you who just joined online, if you don't understand any parts of the working, you can let me know, then I can re-explain it to you. Monish, yes, correct, very good. Can move on to do question 6 now. So overall class, the answer would be A for this question. Okay? Ella, yes, correct. Very good. So once you are done with question number 1, and then when you are doing question 6, you can also check with me the answer for the various parts. I can let you know whether is it correct or not. Yeah. So if you're done with A and B, you can PM me your answer in the Zoom chat. Then I'll let you know if it's correct. By the way, a repeated announcement for the latecomers. I will be giving the answer key for this worksheet at the end of the session. Yeah, so you just need to make sure that you stay till the end of the session, then I'll be revealing the answer key. Winton, your answer for A is correct. B and C not correct. Monish, your answer for A is correct. Winton, you want to give it a try to do for part B again? By the way, a hint for Winton, for part B, you're supposed to use the A equals to V minus U over T formula. And T, you know when, right? Sorry, not T, you know when, as in like, you know when the cars have the same speed, right? By looking at the graph. So the speed, you can sub that speed value in. Then you just do it for either one car will do. Because the time by right should be the same. Anyway, Winton, just to let you know, your answer for B, right? You can kind of see it from the graph, right? Since your answer you said that it's 4 seconds, you look at the graph. When they have the same speed, is it at the line where it's 4 seconds? Right? Isn't the graph? Let me go to the graph page. Yep, over here. Then at 4 seconds is not the same speed. The speed is different. Yeah. So that's why you can know your answer not correct. Monish, your part B correct. Very good. Can move on to part C. Oh, C, you need the material, huh? Okay, can I shall send it to you by the Zoom link? I mean, send it to you by the Zoom chat. Yeah. KG, let me check your answer. A correct, B correct. Very good. Yep, you can move on to do part C. By the way, just a reminder, okay, for part C is that whenever you see question that mention that whether who crossed the finish line first, as well as like whether the vehicle overtake each other or not, key point is they must travel the same distance. Something like the tortoise and the hare example, we said that like the hare, at the start, why he run very fast. Then seeing that the tortoise is so slow, then the hare slow down. But then the tortoise just keep on move consistently, and in the end, the tortoise will reach the finish line first, right? So that means one day the tortoise will actually be able to meet the rabbit, and they travel the same distance. Then the tortoise overtake. It means overall, whenever there is any vehicle overtaking, right, it's always about the distance travel must be the same. Cause like the tortoise and hare example, the tortoise and rabbit example, yeah, is that they must be able to travel the same distance. That's when they would like start to overtake. For Risha's answer, yes, correct. Okay, so for Ashley, about the rounding off, right? This one actually depends on school. Some schools says that okay, you just round off to three significant figures, but there are schools that also say that you have to follow the SF in the question. And like I heard from my Nanyang students, right, is that for NYGH, some students even like some depend on teacher. Like different class teacher can say different things. Some teacher more relaxed. They say that everything just three SF. Then some teacher says two significant figure if you follow the SF in the question. Yeah, so for this question is 2SF if you follow the SF in the question because the numbers given to you is like 3.0, 4.0, 5.0, 6.0. So if you follow the SF in the question, it's 2SF. So I think you have to double check with your class teacher to see what your class teacher say. So for KJ's question, is the distance traveled the area under graph? Yep, correct. Um, as long as it's a speed time graph, area under speed time graph is distance. So yes, you're correct. So area under speed time graph is distance. Yes, Monish, your answer is correct. Okay, due to time constraint, I think I would need to show the answer for this question already. So if you are not done, I would recommend that you don't copy the answer. You take a photo first so that at least you can like give it a try at home at your own time. Then you check with the answer that is in your phone's photo. Okay, so can you all yep, check your answer now. So this is the answer. Let me make it bigger. Hold on. Yep. So if you haven't finished, then you take a screenshot of the answer. So for part A, I believe all of you should be able to get it right because it's just using the A equals to V minus U over T formula. For part B is that when they have the same speed, isn't it over here? That this is the part where they both have the same speed of 20 meter per second. So when you know the speed, you can use the formula A equals to V minus U over T. Yep, so you sub the V as 20. Then the initial speed depends on which vehicle you use. Then in this case, they use vehicle B. You want to use vehicle A, let me see whether is it possible. For vehicle A also can. You want to use vehicle A also can. Yep, then just sub in the, okay, this is for vehicle A, right, isn't it? The vehicle A started from speed of 0. Yeah, lor. So I'll just, let me amend it. It's more for A. Yep, you started from 0. Then for the acceleration, it's here, right? Because this is from the previous part. Yep, so you just sub it in. Then you can solve for T, then done. So for those of you who took photo of the answer, can you all take photo again? Because there's a tiny typo error. It should be car A, not car B. Then for part C, to know who reached the finish line first, that means who is the one that travel longer distance, right? Because if you travel longer distance, more likely you will cross the finish line. That's why go and find the distance traveled by each car. So for the car, each car, you just need to find the area under graph. But the thing is that because the area under, okay, until T 6.5 seconds, 6.5 seconds is here. So it's like for car A, you kind of not very sure exactly what is the y-axis value. You get what I'm trying to say? So if you don't use the equation of motion, you just go by area under graph at 6.5 seconds. For car A, you don't know exactly what is the y-axis value. That's why you need to use the equations of motion formula. For car B, you want to stick to area under graph, can. You want to use back this same formula, also can. Sorry, not this formula. This formula, the acceleration is 0. You can use the other formula. Yep. So in the end, you will realize that for B, they travel a longer distance, means B more likely cross the finish line. That's why the answer is car B. So you need to determine also. So not just the calculation, need to write properly that it's car B that won the race. Yep, like that. Okay, so I would need to move on. If you need to copy the correction, can you take a photo instead? Then you can slowly note down your correction at your own time. So if all right for me to move on after you're done taking the photo, can you click the thumbs up reaction button to let me know? Then I'll move on. Are you done? If you're done, you click the Zoom emotion emoticon thumbs up to let me know. Is KJ and Judy done? Can I move on? Okay, I shall move on because just from just now, like Judy hasn't been around already. Okay, so moving on to the next part. Let's go back to the notes. I haven't finished explaining the notes yet. Okay, so for the notes, so this is the calculation section. So moving on to the next part here is, okay, this one is depends on your school, whether do a teacher cover on this or not. Not all school test on average acceleration. So if your school test, then you need to know this part. Okay, so what exactly is average acceleration? So I think you all know what acceleration is, right? Acceleration is just A equals to V minus U over T. What's average? Like for example, if I say, what's the average score of this class for your physics exam? And then we would say that average is like around the middle scoring student's score. Like example, if I were to rank your scores from lowest to highest, generally, if I find the average of all your scores, it's also kind of around the score where the mid student is scoring. Yeah, so average usually is like the mid point, like the middle. So how to solve such question will be that we need to have V, U, and T to solve. So how do you read such a ticker tape? So you just imagine that this tape, right, is actually tied to maybe like let's say a toy car. Yep, so this toy car is moving to the right as shown by the arrow over here. And for a ticker tape, is usually there is this hole punching machine. So you maybe take it as there's this like nail that keep punching hole on this strip of paper. So this strip a bit like, you know, the correction tape, you know, that kind of like the tape. Yeah. So it's like a very long, skinny tape where there is this machine that keep on do hole punching. So as you can see, the right side is actually the first hole that should be started. Because when you punch the hole over here, the car move to the right. And when the car move to the right, they will drag the tape to the right. That's why this would be the last hole that would be punched. Can visualize it? Because as the car maybe by then move until over here, that means my tape would be like somewhere here, right? Isn't it? So do you realize that by the time you start to punch over here, it would be the middle one? So that's why you will start to punch from the right side, then the middle one, and then if you move even more until like maybe now I can't even see my car anymore, so it would be end up like that. So you will then punch over here. Yeah, so that's why the one on the leftmost, it should be the last hole being punched. Can visualize, right? Okay, then now what we need to do is because we know that you start from the right side, that means technically the right side would be able to find you the value of u because u is the initial speed while v is the final speed. So for the initial speed over here, how to find? So you know that speed is distance divided by time, correct? So in order to find letter u, which is speed, you go and find what's the distance. Oh? Isn't the distance over here 5 cm? And what is the time? And then you have to read the question. So they said that it is put at a constant acceleration. That means the car is speeding up and the arm is punching hole at a frequency of 40 hertz. What does it mean by frequency of 40 hertz? It means that every second it punches 40 holes. So it's a super fast machine. So in 1 second, it can punch 40 dots. So now, how many dots is it? So usually for this topic, we tend to count the first dot as 0. So this is actually 1 dot, 2 dots. So this is considered as 2 dots. So to find 2 dots, maybe you first find 1 dot first. So 40 dots is 1 second. 1 dot would be 1 over 40 seconds. That's why 2 dots would be, you have to times 2 on both sides. Yep, so that's why this becomes 2 over 40 seconds. By the way, just to let you know that usually sometimes you will realize your school teacher will also teach you to count the gaps. The reason is because if you count the first dot as a dot, you might have a tendency of doing careless mistake by counting the first dot as 1. Yeah, because the so the way that ticker tape timer design works is that the first dot is to tell you, okay, I start the experiment. So when you start, you don't count that as the first one. Yeah, so if you look at this, right, usually no students, like if I see 3 dots, they will count as 3 dots, right? If I give you 3 apples, you count as 3 apples. Usually we will count the first one that you see. Yeah, that's why the best way is you count the gaps. So for this section, I see that there's 1 gap, 2 gap. I label right to left is because we start from the right side. We end on the left side. That's why I label from right to left. Yeah, so this time round, you will count it as 2 gaps instead. Yeah, so just take note that ticker tape timer, the first dot don't count. So best is you count as gaps. So 2 gaps means 2 dots. Okay? Then so now for the right side, we would be able to solve for the speed, right? So this is the initial speed. Initial speed will be u. What's the distance? It is 5. But remember to convert to the SI unit. Because distance is not in cm, distance is in meters. Then divided by the time it would be 2 over 40. Oh, because just now, remember I was drawing the cartoon of the car because the car is moving to the right. That's why this would be the first dot that you pierce. Then as your car moves furthermore, you realize that which is the next dot that get pierced? It would be if this hole puncher thing, that this nail don't move, the next dot that I'm punching is the middle dot. I mean, this is the next dot that I'm punching. If I travel until I can't really see the car anymore, then isn't the tape until here? That means the last dot that I'm punching is the leftmost. That's why the leftmost is the last dot. Ella, can right? Okay, so then now you just press the calculator. How much is this? Yep, then you will now know the value of u. Okay, then next would be, let's look at the right side section also. Let's do the same thing. Speed is distance over time. The distance, let's convert to the SI unit. This would be 0.02 meters. And then what's the time? So same thing, it would be 2 gaps. So 2 gaps means 2 dots. So the time is still the same. It would be 2/40. Then after that, you press calculator to see what's the value. Then lastly will be the most difficult part already. Subbing into the formula. So you have the V and U, right? Because U is here, V you have it, which is here. But now the most difficult part is the letter V. Why, letter T, sorry. Why is letter T so difficult? Because it's the part that most students get confused. So you all listen up, listen carefully. For to identify the value for T, what you need to do will be because of the word average. Average means it's like the middle scoring student, correct? So you need to look at your this region. Where is the middle region? Isn't the middle one this dot? Over here, where is the mid? The mid is this dot. So that means you are supposed to count from this orange dot to the next orange dot. So how many dots apart? So either you count the first dot as 0 or you count the number of gaps, which is 1, 2, 3. So this time round, it will be 3 gaps. So it's like 3 dots. 1 dot is 1/40. 3 dots means I need to times 3. So that's why it will be 3/40 seconds. Yep, so that's why the T value will be 3/40. Then you just solve. Then that would be your final answer. So the final answer, it should be, let me write it out. The A value, it should be negative 8.0. And then unit for acceleration is meter per second square. Yeah. So if so far for kinematics, if you have never ever seen this sticker tape before, right? That means likely you're not tested. Yeah. So this one really depends on school. Because different school teach different depth for the IP syllabus. Similar to the equations of motion above. Yeah, equation of motion not all school teach also. Yeah. But I have to cover because it's part of the IP syllabus. Okay, done. That's all. I will leave it to you to slowly press a calculator if you have not done so. Yep. Just write down the final answer, then you can give it a try at home to see if you can get -8. So, all right, for me to move on, are you all done with all the annotations? If done, can you click the thumbs up reaction button in the Zoom reaction icons? Then I'll move on. Or if it's too fast, then you can just take a photo lah. At least you have some annotations. By the way, the answer key that I'll be giving at the end of the lesson won't include the notes. It's only for the practice questions. Yeah. For C, done right? Okay, let's move on. Okay, so moving on to the next part on graph convergence. So need to know that for a displacement time graph, when you look at its gradient, it will give you information on the velocity. When you look at the velocity time graph, you look at its gradient, right? It will tell you the acceleration. And then if you look at acceleration time graph, don't go and interpret the gradient anymore. The gradient doesn't tell you any more information. Instead, you can look at the area under graph. So by calculating the area under graph, it will tell you what's the velocity. For a velocity time graph, if you look at the area under graph, it will tell you the displacement. So generally, how do you interpret graphs? So this is my legend. I find that once you remember this legend, right, it will be very easy for you to interpret graph. So you just keep on follow this four. You follow this four, right? You sure can get it right. Okay, so let me use a basic drawing method to explain to you first. Okay, so for example, I have a race. So let me draw it out. So maybe my start point is over here. My end point of the race is over here. Okay, so can you all follow me and draw it out now too? Yeah, draw it out. Then next, I would need you to prepare about like 4 different colors. So it can be mixture of pen or highlighter, preferably pen. Yep, so I will now be showing you the different scenario of if I have an object that when I look at the displacement time graph, it has a positive gradient and the graph is above the x-axis. By the way, in case you're wondering what's positive and negative gradient, you did learn it before in math. Upward sloping line is positive gradient. Horizontal means 0 gradient. Downward sloping line means negative gradient. Okay? So if my graph were to be like this, upward sloping line and above the x-axis for displacement time graph. By the way, displacement is written as letter S. S is not speed, okay? S is displacement. Time in seconds. So in this case, for the object now, how would I be able to visualize its motion? We would say that you start from displacement 0, right? Means I must start from the start point. Then in this case, since positive gradient, upward sloping line means I'm moving forward. Forward means towards the endpoint. And I'm at the positive side. Positive side meaning, right, as long as you're on the right side of the start line, is considered at the positive side. If I am before the start line, I would be considered as at the negative side. So that means in this case, how is the vehicle moving? The vehicle is moving this way. Because I start from displacement 0, I'm moving forward at the positive side. So I'm moving forward towards the endpoint and I'm on the right side of the start line, which is the positive side. So far I can get it right. If not sure, you can just feel free to ask me in the Zoom chat, okay? Then now if I give you another example, what if it is a negative gradient, but then above the x-axis? You can still follow my pen color because yours should have blue pen, should have green pen, right? Yeah, just follow the color bar. So negative gradient above the x-axis, it will be something like this. Come down. So let's take a look. Since this is above the x-axis, that means it's at the positive side. That means the object should be on the right side of the start line. And next is negative gradient means reverse in direction. Because can you see the downward sloping line means negative gradient. So that means it is at the right side, but it's reversing. Then in the end, it will reach back to displacement of 0. That means it will reach back to the start line. So this is how the object is moving. Next, do you all have like maybe a red pen? So let's do positive gradient and then below the x-axis. So it would be something like this. Yep, so positive gradient means the line should be upward sloping, but it is below the x-axis. So this means that the object is at the negative side. So that means it should be on the left side and it is moving forward towards the endpoint. That means the vehicle is moving like that. Right? You see, you started off with something that is negative. Yeah, so you start off with a negative x value. Then in the end, you travel to 0. You travel towards the start line. Yeah, because below x-axis is on the negative side, on the left side. And it's moving forward, moving forward towards the endpoint. The last one, maybe you have pencil, right? So maybe you can do it with pencil. So it will be negative gradient below the x-axis. So I would draw it as this way. Because negative gradient means downward sloping line. So I draw it downwards and it's below the x-axis. So this shows that my vehicle started from the start point. And then since it's below the x-axis, it will be on the negative side and it's reversing. That means it's getting further and further away from the start point. It means from here, I reverse. So you see, I'm moving further and further away from the start line. So this is how the vehicle is moving. Then after you know how to interpret the gradient and the axis, later you will need to also interpret, is the gradient increasing, decreasing, or constant, or 0? Yep, like that. Then take note that if it's sentence writing, don't use the word rate of change of displacement, because true that, yeah, if you're looking at the gradient, it's the rate of change of, but it's very confusing when you say rate of change of, because there is gradient for different graph, right? You see over here, there's gradient for displacement time graph. There's also gradient for velocity time graph. If you just say rate of change of, then like, who are you referring to? So if you want to say rate of change of displacement, why not just directly tell me the velocity is increased instead of saying the rate of change of displacement is increasing? Write until so long. You just directly write velocity increase. Isn't that more straightforward? So avoid writing rate of change of displacement. Directly write velocity increase, decrease, constant, or 0. Okay? So just to check, everyone, are you all done with all the annotations? Once you are done, you can let me clear the screen. Can you click the thumbs up reaction button on the Zoom emoticon? Charlene, do you need the lesson material, Charlene? Okay, so I shall move on. I take it that you are done copying, right? Okay, so let's take a look at all the graph conversions. So I shall do alternate ones. I can't do every single one because not enough time. The rest you can give it a try on your own at home. Okay. So for the first one, it would be for Charlene, if you need the lesson material, you let me know. So for the first one here, how do you interpret? Same thing, let's use the legend as shown here. So this time round, do you realize that this is above the x-axis? So if it's above the x-axis, that means it's at the positive side. So can you see they write positive side? And next is for the gradient. Remember, this is zero gradient cause upward is positive, horizontal is zero, downwards is negative gradient. Yep, so this time round, if it's negative gradient, and remember, gradient of displacement time graph as shown here, gradient of the displacement time graph tell you the velocity. So in this case, the gradient is zero. Take note, it's not constant. There's a difference. It is the displacement that is constant. Because horizontal line, you see, it's always constant at maybe this value of, let's say, 20. So displacement is constant at 20. But gradient is not constant. Gradient, you follow this one on top here, okay? So gradient is zero instead. And gradient tells you the velocity. Can you follow me and copy it down? Gradient of displacement time tell you the velocity. And this time around, gradient is zero, means velocity zero. So how do you draw the graph of the VT graph? So velocity is in terms of meter per second. Then this time round, we should draw zero. So you just draw a horizontal line along the x-axis. Done. So this would be the answer. Okay, so I shall move on to the third one. The second one, I let you try on your own. Done copying. Should be done, right? Because just a simple graph and very little annotations. Okay, I'm moving on in 3 seconds. 3, 2, 1. I move on already. Okay, so for the third one over here, this is same thing. Let's interpret it based on the top. We look at the gradient. Is it positive or negative? All of them all going up. So as long as going up, it is moving in the forward direction. That's why you realize that all of them, they write forward, forward, forward. Okay? Next, all of them are all above the x-axis, correct? So above the x-axis means they are at the positive side. So you see, positive side, positive side, positive side, and then over here also positive side. Next, you have to interpret the gradient because the gradient tells you the velocity. And in this case, how's the gradient? From very gentle, it became very steep. So the gradient increases. That's why velocity increase. So now how do you draw the graph? For velocity, you have to check that the velocity, the gradient is also positive gradient, right? Gradient is positive. So that means your V value is positive. So I draw as a positive value, increase. When they say increase, just draw straight line. So usually curved line will become straight line. Curved line won't remain as curved line. Okay, so just one thing to take note. Curved line will end up become straight line because it just increase. Okay, so the gradient increases. Because this one, the gradient is constant. So if gradient is constant, that means your velocity, okay, I just give you the answer for this also. The velocity will be constant. Do you see the difference? That's why your curved line cannot become curved line. Your curved line must become straight line because you see the straight line here? This is constant gradient because the steepness is the same. If your gradient, which is the velocity, is constant plus upward sloping, positive. That's why you draw a constant value, like constant at maybe 20, something like that. Constant and then positive 20. As compared to this would be increasing positive gradient, positive velocity. That's why your V value is positive here. The fourth one, you try on your own. I let you try, let you practice. Okay lah, so I shall move on. Should be done with the annotations, right? Can I move on? If done, thumbs up. So for Visha, you done? Can I continue? For the new user, the new Zoom participant called user, if you need the lesson material, you let me know, okay? I then send it to you. Okay, so then let's take a look at the next part over here. Likewise, okay, maybe instead, let me try choose a more difficult one. I choose those below the x-axis one, looks a bit more challenging. Okay, come, I do the last three instead. The rest you try on your own later. Okay, so for the last three over here, so if you were to have this graph, how do you interpret? Likewise, gradient of the displacement time graph tell you the velocity. So let's take a look at the velocity. So how is it? So we see that this one is constant gradient because can you see that the steepness is the same? So take note, it is the displacement that is decreasing. Gradient not decreasing. Displacement decrease. Actually, this displacement is not decreasing. It is increasing. Cause is from zero. It increase in the negative direction. Yeah, that means getting further and further and further away from the start line. Yep. So take note that in physics, right, the negative value a bit interesting, different from math. But you know, in math, we would say that negative 20 is more than zero. But in physics, right, negative 20 is bigger than zero because negative 20 means I got moved a certain distance, right? 20 meters. Zero means I never move any distance at all. I'm at the start line. Yeah, that's why for physics, 20 is the magnitude, while negative is the direction. Yeah, so physics, we will see that magnitude 20 is bigger than zero. So in this case, from 0 to 20, which is far from the start line, you are actually moving further. That's why the displacement is increasing because you're getting further and further from the start line. You're moving a greater distance, but just in the opposite direction. So take note that it's displacement that is like changes, that, but then the gradient is constant instead. Because gradient is the slantness of the line. The steepness is constant. Yep, that's why the gradient is constant. So how do you draw the graph? Next is need to decide your V. Do I draw above or below the x-axis? So to decide, you have to see the gradient. This is negative gradient, right? Cause upward sloping is positive, downward sloping is negative gradient. So this is a constant negative. That means when you draw your graph, you should draw it as negative constant. So this is the answer. Can understand? Okay, then the next one, I skip one, I do the third one. So for this graph, how do we draw it? So likewise, look at the gradient because the gradient tells you the velocity. So in this case, what happened to my gradient? From steep become like horizontal. Horizontal is zero. That means it's from big to small. Big to small means decreases. Then next, downward sloping line. Downward sloping line is negative gradient. Means that my velocity, I need to draw negative value. So I should draw my x-axis higher. And then it's decreasing. So that's why I would draw from, in this case, I would decrease. And this time around, decrease is this way. Not this way. Okay, this is wrong. It should be this way. Because remember, as mentioned, if this is example negative 20, I told you, right? Negative 20 is bigger. That's why decrease is like negative 20, which is a big number, 20, decrease to 0. Do you realize my speed is decreasing? From reversing at 20, I come to a stop. This is speed 0. Isn't 0 the slowest? Yep, so that's why negative 20 to 0 is decreasing speed. You are slowing down. Okay? Yeah, like that. The second one and the rest, you all can give it a try lah. Then after you're done trying already, then you can check your answer to see if it's correct or not. Okay, so that's all that I'll be going through for this section here. Are y'all done? If done, can y'all click the thumbs up reaction button to let me know? Done copying? Okay, due to time constraint, I think I need to move on. If you're not done, you just take a screenshot or take a photo of it, then I'll move on already. Okay, so anyways, for the as mentioned, my answer key, I will only be showing the answers for the worksheet, MCQ, and open-ended question. This is note section. Note section, I'm not giving the answer key for it. So I will be showing the answer here. Can you all take a photo of the answer? Then after you try it, you can check your answer. So the note section here, this answer not in the answer key. Can everyone take a screenshot now? Can take a screenshot now. I'm moving on in 5 seconds. 5, 4, 3, 2, 1. Okay, moving on. For the next part, can you all take a screenshot first? Then later I scroll down to show you the second half of this page. And so likewise, take a screenshot because the answer key for this not provided. 5, 4, 3, 2, 1. Okay, moving on. And then the last part, the one that just now I was like trying to go through with you. Take a screenshot again. 5, 4, 3, 2, 1. Okay, moving on. Okay, because Overmark says that the lesson is a 1.5 hours lesson, and apparently it's impossible to rush two topics in just 1.5 hours, right? Because your school also teacher take more than 1 month to finish this whole chapter. So maybe I will just sum up the lesson first. If you have the time to stay back, I will continue to go through I will just extend the lesson and continue to go through like the behind pages. But if you are not able to stay behind, let me give you the answer key and all first. So I will end off the lesson first, then I'll continue to teach the remaining pages lah. So the behind part, optional for you whether you want to stay on or not. Okay. Yep. So at least I finish up the 1.5 hours that Overmark is saying. Yeah. So anyways, in conclusion, overall, if you want to learn more about kinematics, actually for my classes, I will be starting kinematics next week. Yeah, for my Sec 3 IP physics class at Bukit Timah branch. So if you find that like wow, like just now the way I explained kinematics, you find it like very hard to understand, then if you find that you need tuition, these are the details. So if you're interested to sign up, you can actually scan the QR code. So you can if you're undecided, you can actually sign up for like a free trial lesson first. So it's like it's one free lesson to let you experience the actual lesson. Then if you feel that okay lah, you like it, then you then sign up. Cause today's lesson, just to let you know, I am teaching a little bit fast. Yeah, because I take it that you already have background knowledge from school. But when I teach it as a regular tuition class, I teach really slowly, concept by concept, and then it's like one topic of kinematics, I actually take 4 weeks to teach finish. Yeah, so I actually go through in detail. So not as fast as today. Like today is just a summary lesson, just more of like a teaser to let you experience how overmark tuition is like. Yeah. So yeah. So for English, we don't have IP class. It's more of like a O level class if you are interested. And then for Overmark, they are going to have free gift, yeah, as per usual. Yep. So this time around, they are giving away curated notes. So if you are interested to win curated notes, you can scan this QR code and write a review on how you find the lesson for today. Yeah. Then the top review, the best review will get to receive the curated notes. Yep. So what you can say is that you can mention that like how you find the WA this revision session, and then like what subject you attend. So this is the Sec 3 IP physics, and then which tutor. My name is Miss Felicia. In case you miss out the starting when I was like introducing myself. So this is my name. Yep. So if not, then I shall now show you the answer key for the worksheet for today. So I take it that you all should be done scanning by now. Yep, so this is the answer key. Yep. So the answer key only have the answers for the MCQ and open-ended section. So if you want the answers for the notes, like all the graph, as you can see, you flip through the pages, there are more graph conversions, and as well as any like fill in the blanks in the worksheet. Notes section, not in this answer key. You can download that and take a look. You will know what I say already. Yeah, so from I will end the lesson here. If you're interested to stay on, you can stay on. But if you feel that you need to leave already, yeah, you can feel free to drop out from this Zoom session. So yeah, that will be all for today. So hope you all have at least learned something and clarified some of like parts that like you all might be uncertain on. Yeah, so I'm Miss Felicia. So thanks for joining me today. So yeah, I'll see you then for the next few events. So just follow Overmark on social media, and then we will have more and more free lessons along the way throughout the whole year also. Yep, so that's all for today. Bye bye. If you need to drop off, if not, I'll continue on with the second half. Yep. Okay, let me switch back to the worksheet. Okay, so for the notes, I'm done for the displacement time graph. I will now move on to the velocity time graph. Okay, so for velocity time graph, likewise, I also have a legend. So for this legend over here, you just follow, then you will know what's going on already, like how the vehicle is actually moving. So if it is positive gradient, it means that the vehicle is accelerating. Because positive, as mentioned, the line is going up. If the line is going up, like your velocity time, do you realize you're speeding up? Yeah, also that's why positive gradient is acceleration. Then if it's negative gradient, then of course it's like slowing down from a high speed to zero. So this is deceleration. So take note that for deceleration, we can interpret it two ways. So can you follow me and write it down? Deceleration can be interpreted as slowing down because I decelerate. Slowing down in the positive direction. Or you can interpret it as, because got the word acceleration. Can you see deceleration come from the word acceleration? So you can treat it as it's also accelerating. It's like speeding up, but in the negative direction. Because deceleration is actually just negative acceleration. What am I writing? Sorry. What I say and what I write is different. Yep. So A is negative. I put minus sign, okay? So when your acceleration value, like, you calculate A equals V minus U over T equal, if your calculator answer is negative, then that is called deceleration. So deceleration is either you slow down, but in the positive direction, or you're speeding up, but in the negative direction. That's why you add in the negative sign to represent negative direction. So likewise, you have to see whether the graph is above the x-axis or below the x-axis, because above the x-axis means that your v value is positive. Positive velocity means I'm driving forward. But if it's below the x-axis, like maybe I draw like that, vt graph, right? I draw the line like here. Do you realize if my v value is negative, isn't negative reversing? That's why v negative means below the x-axis, it is reversing. And likewise, don't use the word rate of change of, because rate of change of got rate of change of displacement and rate of change of velocity. Yeah, so why not be specific and say that you are looking at acceleration instead. Okay, so likewise, let me pick a few random ones to go through. Maybe I pick the last few over here. Oh no, what happened to the lines? Okay, let me take a look. This one, I think you can just like correction tape or erase this one. I don't know why I got this extra graph here. Okay, let me erase the lines. Okay, so it's just like that. Okay. So for this these two graph, how do we draw it? Okay, so let me draw it out. Okay, so always interpret the gradient, cause gradient of VT graph tells you the acceleration, which you can see it from the front page over here. There, velocity time graph, when you look at its gradient, it will tell you the acceleration. So to convert from a VT graph to acceleration time graph for this one here, you look at the gradient. So for the gradient, which is the acceleration, how is the gradient? So you can see that it is changing from very steep to become very gentle. Because remember, for gradient is always upward sloping line is positive gradient, horizontal is zero gradient, downward is negative gradient. So in this case, if my graph is becoming towards zero, that means my gradient is decreasing. So take note, it is velocity that increases, because the velocity from zero become like a very big value, maybe like 20. It's the velocity that increases. But the acceleration decrease instead, because your slantness decreases. Okay. Then in this case, if you decrease, you also need to know, do I drop above or below the x-axis, right? So you have to check your A, is it positive or negative? This is upward sloping line. That means this is a positive gradient. So that means now I will draw acceleration at the positive range. So acceleration, which has a unit of ms minus 2, I have to draw it in the positive region. That's why I'm going to draw in this space here. And I should draw decreasing. Remember, curved line can only become straight line. And how to draw decrease? Come down, straight line. And then this time around, the straight line won't reach the zero mark because the gradient haven't become horizontal yet. Only when it becomes horizontal, then it's zero. So this time around, you just stop somewhere above the x-axis. Yeah, so this is how you draw it. Okay, then let's take a look at the next one, the fourth one here. Let me erase it. Yeah. Okay, so for this graph, which is a slant line downwards, same thing, we interpret the gradient. So for the gradient over here, how is it like? The gradient is actually constant, right? Can you see from the top and to the bottom, the slantness is the same. So if the gradient is constant, and then this time around, the line is coming down. Down, isn't it negative? That's why it's constant negative acceleration. And remember what we have just written here? Negative acceleration can mean deceleration. That's why do you now see the word deceleration over here? Yeah, because negative acceleration is deceleration. That's why now when we draw the graph, we should draw it in the negative region. Then likewise, label the axis. And we should draw constant. Constant, no? Constant at like a particular value, maybe like negative 20, something like that. Yeah, so this is how you draw it. Okay, so let me demo one more graph just to check. Are you all done with all the annotations? Make sure you write in the explanation also so that you know how to derive the answer. So once you are done noting down, can you click the thumbs up reaction button to let me know? Then I'll move on. For Ella and the person by the name called user, are you all done? I move on. Okay, so moving on. Next one, okay, since I choose upward, downward, okay, I choose something below x-axis. So maybe I choose this one here. Okay, let's do this. Okay, so likewise, let's look at the gradient, which tells you the acceleration. So how's the gradient? From very gentle, it becomes very steep. So that means the gradient increases. Okay, and next is the gradient is downward sloping. Remember, I keep drawing this, right? Yep. So downward sloping line is negative. So this is negative. So how would I draw this graph? I need to draw it in the negative region. So I would draw the x-axis higher. Yep. And this time around, I should draw it increasing. And now the question is, which way is increasing? Is it this way or is it this way? Do you all know how to draw? So remember, just now I was telling you, the math and physics is opposite. Can you give it a try before I show you the answer? Do you think it goes up or goes down? Remember, I told you, curved line can only become straight line. So it is definitely this way or this way. But which one is it? You want to try? Okay, I shall review the answer in 3 seconds. 3, 2, 1. The answer is this way. Do you get it right or not? Okay, so how come is it this way? It's because this is increasing. Remember in physics, like if I have like maybe -5 versus -20. -20 is bigger than 5 because this is saying that I'm reversing at the speed of 5. And this one I'm reversing at the speed of 20. Isn't reversing at 20 like more? That means 20 is faster, is bigger, isn't it? Yeah, because math and physics is opposite. Math, -20 is smaller. But physics, -20 is bigger instead. Yeah, so that's why if you want it to increase, that means small to big, it should be -5 to -20. Then next is, in case you're wondering, why never start from the origin, is because the gradient here didn't start from 0. Because gradient is the A value. If my gradient is 0, my A then is 0. So since my A started off with a certain value, I must start off with a certain value. Yeah, so this is how you draw it. Okay, so for the rest of the graph for conversion, you can also give it a try at your own on your own time. I would give the answer now because it's not given in the answer key. Hold on. Okay, let me show from the front page first because the front I also skipped some. Wait, let me see whether can I shrink everything in. Yes, like that. Okay, yep. Can you all take a screenshot now? Then for Ashley's question, why it doesn't start from 0 and instead it's -5 when the velocity is 0. Okay, wait. Let me go back and take a look after you're done screenshot. Done, right? I move on. Okay, then the next part here, let me make it bigger. Okay, yep. You all can take a screenshot now. Okay, then I continue on to the next part here. Yep, you can take a screenshot again. So over here, you are saying that velocity started from 0. Then because at the start, when it's at 0, it is already accelerating. Yeah, can you see it's accelerating. So over here is trying to say that is it accelerating at that time? Only if it the velocity meaning 0, 0, 0, 0 all the way. Maybe it maintain at a velocity of 0 for maybe 10 seconds. Then yeah, if I'm always stationary for 10 seconds, that means I am not accelerating. You then start from the 0 for acceleration. But here is at the start. From 0, I already changed my speed now. That means I am already undergoing some form of acceleration or deceleration. That's why there must be some form of acceleration or deceleration at the start. So overall, best is you always interpret based on the gradient. Because gradient of a VT graph tell you the acceleration. So does that, okay, good that you understand now. Okay, so let's take a look at question number 7 to see how we can apply such graph conversion onto a worksheet question. So let's take a look at question number 7 now. Over here. So the question says that describe the motion of the object. So take note that whenever question asks you describe motion, right, there is a skill that you need to know whenever it's for kinematics question, which is you have to always interpret in terms of V and A, velocity and acceleration. You need to take into account both. The reason is because when an object is having a velocity, it is moving, right? It's in motion. Then when an object is accelerating, it is also moving. So this is skill number 1 that you need to have. Skill number 2 would be whenever you have like time given, you have graph, take note, okay, whenever you have graph, you must always cite the data. By right, this skill you should already have from lower side because lower side also whenever got table and graph, you must always cite the data. That means like need to cite the value of 20, need to cite the value of 12, negative 15, need to cite all these values. Okay, so in your answer later, we must have all these. So now we will analyze section by section. Okay, so we start off with the first section first. So this time round, I will be asking you all to participate. If you know the answer, you tell me. But if you're not sure, can you just say unsure? Then I'll just guide you along. Okay, so we start off with the first section over here first. So this part over here, how do we describe the velocity? You just read the V value accordingly, like the V value here and the V value here. So for velocity should be quite easy for the first section. Maybe can I start off from Risha first? So I ask Risha, then user, then KJ, then Judy. Okay? So I start from Risha first. So Risha, how would you describe the velocity for this part here? So you see the V from this value become 20. So what happened to the V value? Increase, decrease? Which one is it?
Increase.
Again, cannot hear clearly. Muffled.
Increase.
Yes, thank you. And then the velocity, is it positive or negative?
Positive.
Very good. Everyone, can you follow and copy it down? So done with analyzing V, next we need to move on to A. So to tell the acceleration, it would be the gradient of the VT graph, right? Can Risha finish up for this section? How would you describe the gradient here? Is it increase, decrease, constant, or zero?
Increasing.
Very good. Then is this gradient a positive, zero,
It's,
or
po- it's positive.
very good? Everyone write it in. So we can say that it's a positive increasing acceleration. Okay, then moving on to the second region. So second region, can I get user to help me out? So how would you describe the velocity? Just look at the number here, then velocity, like that. So how would you describe the velocity for this?
Like constant.
Very good, cos constant at 20. And then same thing, let's follow here. Is it positive or negative velocity?
Positive.
Yes, very good. Okay, then next, let's take a look at the acceleration, which is the gradient. So how would you describe the gradient here?
Like no acceleration.
Yes, very good. Zero. Because remember, we always say that for gradient, horizontal line is always zero. So take note, it is the speed that is constant. Gradient, not constant. Gradient is zero instead. Because must follow this. Very good. Thank you. Okay, then we move on to the third section. So for the third section here, can I get KJ to tell me how would you describe the V value? You look at the V from 20, then become like this. So KJ, how is the velocity? Decreasing, very good. And next, need to also describe like positive or negative. So how's the velocity? Yes, correct. Because it is positive 20, then later become positive 10, then eventually reach zero. So it's always positive throughout. Very good. Next, let's move on to the gradient, which is the acceleration. So in this case, you said that it's a constant deceleration. Very good. Yep. So negative acceleration is deceleration. Yes, very good. Shows that you understand. Good job. Because remember, people, downward sloping line is negative gradient. Okay, then we continue on to the next section here, which is this line here. Okay, so next, can I get Judy? Then the last section, I'll ask Ella. Okay, so Judy, how would you describe the V over? Oh wait, Judy is always usually not around. Okay, then I move on to Ella first. Then later, the next section, I'll ask D to, I'll ask Clover to explain to me this part. Okay, so for Ella, what's the yellow color's region velocity? Negative and decreasing. No, remember I told you physics and math is opposite. Yeah, so you look at this 0 versus negative 15. Then remember in math, we said that 0 is bigger than negative 15. So that means if it's physics, it would be the other way around, right? Because negative is the direction, while the number here is the magnitude. So this is trying to say that at the start, the person not moving. So it's like 0 speed because it's like stop moving. Then later, he is reversing faster and faster and faster and reverse until at the speed of negative 15. So isn't this increasing? So actually, this is a negative V value and it's increasing speed. Okay, so it's increasing instead, Ella. Okay, then Ella, can you continue on? How about the acceleration? How would you describe it? Constant and accelerating. Yes, because you are speeding up, your speed is increasing. Very good. So let's write down constant positive acceleration. Can you see my positive sign? Okay, constant positive. Then we move on to the next section over here. So can Clover describe to me how is the velocity for this section here? Clover. Velocity is decreasing. Yes, very good. Because from reversing, now the person stopped moving. Then need the sign. Do you realize, you see, must always include the positive or negative sign. So is this positive or negative velocity? Yes, very good. Then Clover, can you continue to finish it up? How about the acceleration, which is the gradient? How would you describe it? The rest of you, you can think of the answer too. Then once Clover says the answer, you can check whether did you get it correct or not. Yeah, y'all give it a try while we wait for Clover. So Clover, how's the acceleration? If you're really not sure, you can say unsure also lah. Oh wait, you said okay, positive, and then the gradient, is it like increasing, decreasing, or constant, or zero? Need to describe. Like you see your velocity, you got describe decrease. So over here, how would you describe? Increasing because it's getting steeper and steeper and steeper. Yep. And now we can piece it up into proper sentence to write in the answer. Yeah, so you can just say that for the first section, yeah, you can say that, oh, the V increase from how much to how much. Yep, so let's write it down. So V increase from 0 to 20 meter per second. For the acceleration, don't need to calculate because this is a sentence writing. You just say increasing good enough. Then increasing, positive. Positive means acceleration. You slowly write it down as answer on your own. Since after you're done writing, you can still check with the answer key provided. Okay. Then next part over here, we would say that, yep, the velocity is like constant at a positive value of how much? I can say that it's at positive value of, oops, let me change the color, at the speed of 20. Yep, because remember, you must mention about the velocity. Then for the next section, you just say that from time 12 to time 18, the V decreased from how much to how much? It decreased from 20 to, usually you want to write 0 can, but for this chapter, we tend to like to write to at rest. Yeah, so that means when object is totally stop moving, we will use the word at rest. But you write V equals 0, velocity 0 is still okay. Yep, then you continue right now. Acceleration is like constant. Yeah, the object is undergoing constant deceleration. Then you move on to the next part here. So you said that the velocity is increasing, right? So you must say that it's increasing from what value to what value? So increasing from rest to negative 15 ms minus 1. Then you say that it's undergoing constant acceleration, but in the reverse direction because of the negative sign. Then for the last section over here, likewise also describe the velocity decrease from negative 15 to 0. Then you mentioned that, oh, it's undergoing a increasing, this time around take note, because this time around your speed is slowing down. That's why this time around, because your V is negative, end up here actually the gradient, although it is positive, but due to the negative speed, in the end, it became negative. Yeah, because, wait, sorry, this one, this one I realized I didn't correct it. This part is wrong though. People, can you change it? The V here is not positive. The V is negative 15, what? Isn't the V negative? Yeah, then with a negative velocity, and then when you combine with the positive acceleration, overall it becomes negative because you are decreasing in speed. Decreasing in speed means deceleration instead. So that means for your A value, because you are slowing down, can see your V decreases, you come to a stop. That means you are actually decelerating in the reverse direction. Yeah, then remember this is like double negative because deceleration means A equals negative. Then reverse direction means negative. Double negative, you get the positive here. Yeah, like that. Double negative, get positive. So you just have to look at your speed also. If you're slowing down, means deceleration. And then this is negative sign, means reversing. That's why it's decelerating in the reverse direction. Done. So this would be the answer. Oh yeah, over here I mentioned, right? Try not to write 0 speed. Try to use the word come to a rest. Yep, like that. Okay, yep, so that's all. So you just piece them up in proper sentence. Remember that always start your sentence as from what timing to what timing. So you start from the timing of 0 to 7 seconds, comma, and then you write out all the description. Okay? Yep, so once you are done copying everything, can you click the thumbs up reaction button to let me know? Then I'll move on. Is Clova and Risha done? Okay, great. Let's continue on. Okay, so back to the notes. I haven't finished yet, right? I only finished VT graph. So done with VT graph. Let's move on to AT graph, acceleration time graph. This is on page 18. Can you flip to page 18 now? Okay, so for acceleration time graph, don't need to look at the gradient anymore because if you refer back to this part here, AT graph, there's no more arrow that says gradient. That's why you just interpret VT graph as per what it is. So that's why like over here, there don't need to read the gradient anymore. Above the x-axis means it is a positive A value. That means that's positive, right? And acceleration, below the x-axis means my A value are all negative. That means deceleration, just like that. So this is like, oh, constant and this value, constant, above x-axis, acceleration. Let me highlight it. So above x-axis is acceleration. So these first three graphs, they are all above the x-axis. You use acceleration. Then for the next few graphs that is below the x-axis, you use the word deceleration. That's why I scroll down, you all should be done highlighting by now, right? Can I just color coding lah. Acceleration is orange. Then the green color ones is deceleration. So deceleration, you see, they are all below the x-axis. Yeah, just like that. Then just check the graph, increase, decrease. Then follow the physics side, not the math side. 0 become negative 20. This is increasing, okay? You see the word increasing? Math and physics is opposite. Okay, so don't forget about that. Okay, then the next part over here would be on free fall. Oh yeah, by the way, actually, okay, because I don't want to hold your back too late. I aim to at least finish by 10 p.m. because that is 2.5 hours already. Yeah, so now that I've already explained acceleration time graph, actually you should be able to know how to do question number 3 as well as question number 8. But question number 8 a bit too long. So maybe we do question number 3, we'll do. Yep. So can y'all take a look at question number 3? think carefully. It's a difficult question. It looks simple but difficult. Can you give it a try? Then after you are done trying, can you PM me your answer? What do you think is the answer for question number 3? Yep, so you PM me your answer in Zoom chat. What's your answer for question number 3? Prova, very good. Wow, I said that it's a difficult question and you got it right. Good job. You can do question 8. Well, Ashley also got it right. Very good. Risha also got it correct. Well done. How about the rest of you? What's your answer? Once you are done with question 3, move on to question 8. So the rest of you unsure, is it? I review the answer because there's no calculation. Don't need take so long to decide on the answer actually. Okay, so the answer is C. Why? Because can you see that as long as it is above the x-axis, you are still accelerating, right? Even until here. Okay, or maybe even until like this point here. Even until this point, I am still accelerating. That means I am still speeding up. So throughout the whole green color section, I am becoming faster. I write down. So can you all write down the explanation if you got this question wrong or don't know how to do? So throughout the whole green color region, I'm becoming faster. It is only when the graph goes below the x-axis, that's when this is deceleration. Deceleration means become slower. So that means I have been becoming faster and faster and faster and faster all the way until point C, which is like this point here. Only beyond point C, I then slow down. So actually your speed is the fastest until point C, or because all the way until point C, you are constantly becoming faster. Can understand? Don't need to look at gradient, because this is a acceleration time graph. Acceleration time graph, just read the graph directly. Don't need to look at the gradient. Okay, so I shall move back to the notes. So for the last segment over here on free fall, one of the very common mistakes among students, listen carefully, is that whether got air resistance or not, right, the graph is totally different. And whether heavy or light object, also totally different answer. So let's take a look. When don't have air resistance, right, your graph is fixed one, just a straight line up. And then no matter heavy or light object, right, the graph is the same. So let's label it heavy slash light object. The graph is the same. They fall at the same speed. Why? Because mass won't affect, because this is a VT graph. For a velocity time graph, velocity is distance over time. You realize this equation here on velocity, there is no mass inside. So that means mass don't affect the speed. You might be thinking that maybe the mass affects the kinetic energy. True lah, because object that is heavier got more kinetic energy. But question is not asking on kinetic energy. Question asking on speed. So how's the speed time graph for heavy versus light? The answer is the same because mass is not in the equation. As compared to if got air resistance, if got air resistance, heavy and light, the graph is different because if the person is heavier, in order to reach this horizontal line, you know, right? The horizontal line part, this is called the terminal velocity. To reach the terminal velocity that is mentioned here, you have to be weight equals to air resistance. For a heavier object, your W is bigger, right? So you see, for a heavier object, your W is bigger. If your W is bigger, means I need a bigger air resistance. And how to get a bigger air resistance? I need to fall through a longer duration to get more exposure to air, and such that because of weight, W equals mg, you are constantly being pulled down by the Earth's gravity. So the gravity will make you accelerate because G is gravitational acceleration. So that's why you see as you fall down, you keep accelerating, your speed keep increasing. So for heavier object, I need to continue to fall. Because as long as I continue to fall, that means my speed will keep increasing and increasing and increasing. That's why I need to fall through very long, such that my V value can be big enough, such that with a great enough of a speed, air resistance will then be big enough. Because what are the factors affecting air resistance? Factors affecting air resistance is speed. Like example, right now, you are now sitting on your study chair listening to my Zoom lesson here. As long as you are stationary, by right, there is not much air on you, ma. As compared to maybe you sit in a sports car where the top part of the vehicle is like removed. Then wow, the car drive very fast. You can feel a lot of the wind, right? That's a lot of air resistance. So take note that air resistance is affected by number one, the speed of the object. The faster you are, the more wind, the more air resistance, as well as surface area. That's why usually skydiver they open the parachute to increase the surface area to have greater air resistance. Okay, then yep, so that's why for heavier object, you need to go greater speed. That's why heavier object, the speed is higher than the lighter object. So with a greater speed, greater air resistance, then can be equals to the greater weight. That's why the graph is different for heavy versus light object with air resistance. But without air resistance, it's just all objects are falling at G equals to 10. Remember, this is called, G is called the gravitational acceleration. This formula you all should have learned before in lower sec, the W equals mg formula to find weight. Yeah, so this is the acceleration. So all objects will fall at the same acceleration. Done. Okay, so I shall scroll down. Are you all done? If done, can you click the thumbs up reaction button to let me know? When Ashley and Risha done, let me know, then I'll move on. Okay, so moving on to the last part over here, need to know how to interpret the graph. So this is about the graph conversion again. So if you have understood how to convert all the graph that I've been going through just now, by right, you all should know how to do it lah. So this part here, need to know the common examples like ball thrown up into the air, and then ball like you throw down, then like basketball like that, bounce up, how you draw the displacement time graph and acceleration time graph, and also need to know skydiver like fly, then halfway he pull parachute, and then need to know what happens. So this is the part where he start to open the parachute. Okay, can you label it? Then for the graph drawing over here, I'll leave it to you to practice it on your own. So I shall show you the answer now. You take a screenshot. Then after you try it, you then check with your screenshot. Okay, so come, can you all take a screenshot of the answer now? Done, right? Okay, so I shall move on. So yeah, you can give it a try with question 4 and 5 after you done with doing this graph conversion. Yeah. Then I think, oh yeah, then let's take a look at this part over here. So need to know how to interpret the skydiver's motion. So take note that whenever they ask you to explain, right, can you try to take note to include the direction of the forces? So usually when they ask you to explain in terms of forces, right, remember to include the direction. Write down. Yep. So yeah, so you should mention like in the end the direction, how is it like upward, downward? Yep. So this kind of question by right, actually all schools notes should have. So this part, you should be able to answer it. So I shall leave it to you to give it a try. You just need to refer to the graph on the previous page here. You refer to this graph and then you answer section by section. So this is like the model answer eventually if they were to ask you such skydiver diving down kind of scenario. Okay, so this one I'll let you try on your own. I'm going to show you the answer now. Likewise, you take a screenshot. Okay. Wait, let me make it bigger. Okay, can. Yep, you can take a screenshot now. Should be done, right? I count down 3 seconds. 3, 2, 1. Okay, moving on. Okay, so next would be let me see anything else. Okay, let me show you the working for question 2 because question 2 I find that it's a little bit difficult. Yep. So later, right, when you do your t value here, it would be from here, this point here, to this point here. So this is actually same thing. We would count, this is like considered as 1. Let me just write down the working so that next time when you, so can you see these are gaps, 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 and over here is another gap. Then from the gap, you then jump to the dot. So that means this gap to gap, you count as 1, gap to gap second time, gap to gap third time, gap to gap fourth time. So this is a 4.5. That's how they have this number here, 4.5. Yeah, because you just refer back to the notes just now, but on the average acceleration page, yeah, where I mentioned that average acceleration, because average is like the middle scoring student, so it's mid to mid. So this section, the mid versus this section, because this section got 3 dots, so the mid is actually over here. So this is the mid to the mid. Yeah, so can you all take a screenshot so that you have the explanation on how to solve question number 2? Yeah, so take the screenshot now. Yep, then I'm done already. That's all for the lesson here then. Yep, so you give it a try to practice all the questions in there, and then you just check with the answer key that I've been providing so far. Yep, so then I'll end of the lesson here. So if you have any other questions, you can stay back to clarify with me. Then if not, you can drop out of this Zoom meeting already then. So hope you all have benefited from the lesson here then. Yeah, so I'm Miss Felicia signing off. Bye-bye.